My name is Meg Schwarzman. I am one of the associate directors for the Berkeley Center for Green Chemistry. My area is health and environment. And it is my great pleasure to introduce this next session. To put it in context for a moment, if an overarching goal of green chemistry is to transform the material basis of society to substitute hazardous chemicals with safer ones, how do we actually make those choices? How do companies or governments know a safer chemical when they see one? And how do they weigh the trade-offs that are inevitable in the complex decisions that are made in designing chemicals, choosing materials, and making products? How do we make the meaningful substitutions that Director Debbie Rafael described so eloquently this morning? One tool for doing that is the green screen for safer chemicals, and that's the subject of this next session. It's a method for comparative chemical hazard assessment, and it's an interesting model because it's publicly available, it's fully transparent and free, and it's used by a growing number of large manufacturers whose products range from chemicals to electronics to apparel and footwear. And we're fortunate today to have two people here who've been engaged in the development and implementation of the green screen since its inception. We'll hear first from Lauren Heine, who co-developed the green screen, and then from Cory Robertson, who uses it in his work at Hewlett-Packard. And we'll have a good amount of time for an interactive discussion with them after they've each had a chance to present. So first, I'd like to welcome Dr. Lauren Heine, who is the consulting co-director for the nonprofit Clean Production Action, and she's the director of the Green Screen program. In her work, she applies the principles of green chemistry and green engineering, and also multi-stakeholder collaboration and design for the environment in the service of designing safer products and sustainable business practices. Lauren currently serves on the California EPA Green Ribbon Science Panel, and she works closely with US EPA Design for the Environment program, and you'll see the overlaps as she describes green screen. Working on the development of criteria for safer chemicals. She also co-chairs the subcommittee charged with developing a buyer's tool for Walmart's chemical-intensive product network. From 2003 to 2007, working in partnership with Design for Environment at US EPA, Lauren led the development of Clean Gradients, which is a web-based platform for identifying greener cleaning chemicals. She earned her doctorate in civil and environmental engineering from Duke University. She was a AAAS fellow with the US EPA's Green Chemistry program and also taught organic chemistry labs at Bowdoin College. Please join me in welcoming Dr. Lauren Heine.
Thank you, Meg. Can you all hear me okay? Okay, great. Thank you very much. It's a great pleasure to be here and to see the incredible progress that the center has made and my friends and colleagues have achieved here. And I feel that this is a really exciting trajectory of lots more to come. So I am going to hopefully move this forward. Okay. Very briefly, Clean Production Action is a nonprofit organization that works with governments, NGOs, and others to advance green chemistry and safer product design. And when I began my career, I had oops, it's off. Protect me from turning it off again. When I began my career, I began as a fellow, with a AAAS fellow in the Green Chemistry program, working with Paul Anastas. And I think it was the first week I was there, I met the then head of Design for Environment program, who said to me, "So, how does it feel to know that your degree is obsolete?" And I said, "Wait a minute, my diploma is still degassing. What do you mean my degree is obsolete?" And he said, "This end-of-pipe treatment, that's history. It's all about upfront design." And so working for Paul, very quickly I had memorized the 12 principles of green chemistry and continue to use them often in thinking and as guidance. and recognized that of the 12 principles, 5 of them speak directly to inherent properties of molecules, minimizing potential for accidents. That could be explosivity or reactivity, design for degradation, inherent biodegradability, and the rest have to do with inherent toxicity or hazard, because green chemistry is the design of products to reduce or eliminate the use or generation of hazardous substances. And so the green screen is very much a focus on that hazard piece of green chemistry, because it's very difficult to implement all of the principles of green chemistry without having metrics around hazard. So the way the program began, and I'm going to do just a very brief overview of the program, and then Cory's going to speak, and we hope to have lots of time for questions. So tell me to slow down if I go too fast, but I want to make this quick. So the development of the green screen began because states were looking to ban individual chemicals like decabrominated diphenyl ether. And they were asking, are safer alternatives available, or even are alternatives available? Because we can't ban something if there are no alternatives, if it's considered necessary. And so Mark Rossi and I did a project looking at a number of flame retardants used in television casings. At the same time, I was working with DFE for their furniture flame retardancy partnership, looking at alternatives to penta-BDA in furniture. And as part of the DFE partnership, they took this was volume 1. Volume 2 was, I think, 500 pages. This was about 300 pages. They took all of this information, all of the toxicity assessment information, and boiled it down into this hazard table, which is a lot of information assumed here. And they also developed some interesting strategies for redacting information. So it would be possible to, for example, on this flame retardant here, you could evaluate the hazards associated with the flame retardant, but it was called proprietary A, chloroalkyl phosphate, that sort of thing. So they had ways of masking certain proprietary information, but providing all of the summaries of the hazard assessment. And this was a great step forward. And the original assessments were a little bit crude compared to where things are now, because this is a rapidly evolving field. But this really set an important stake in the ground. But at the end of it, people were still asking questions. They were saying, how do I interpret this? How do I know which one is better? None of them looked good. None of them did. And just as a note, when DFE does alternatives assessment, they're not endorsing anything. They're just comparing. And so there's a chance that none of them will look good. But sometimes some do look good. And so people were saying, what do I do? Do I count H's? Do I count M's? How do I make a choice here? But EPA was not in a position to make recommendations. They can't endorse one chemical over another. And that was a role that we could fulfill with the green screen. So the green screen is a method for comparative chemical hazard assessment, CHA. As I mentioned, it builds on the US EPA Design for the Environment approach, and also other national and international precedents. There's OECD work, there's globally harmonized system for classification and labeling, and more. There's, Debbie talked a little bit about some of the European efforts, Canadian efforts. Importantly, it's publicly accessible, transparent, and peer-reviewed. And it complements other sustainability tools, including green chemistry. Green screen is not green chemistry, but it can support green chemistry by identifying safer solvents, safer reagents, et cetera. You need to do a hazard assessment before you can do a risk assessment. Businesses use hazard assessment to prioritize alternatives before they need to do a risk assessment. It complements life cycle assessment. Life cycle assessment does not get very granular when it comes to hazard. Small amounts of chemicals in products. It's really good with sort of mass flow approaches. And CHA is a form of alternatives assessment, but alternatives assessment can be broader too. You can incorporate price, performance, manufacturability, things like that. So I always say that a tool like green screen for chemical hazard assessment is necessary, but not always sufficient for sustainability. So over the last few years, there's been a lot of adoption. And you're going to hear from Cory Robertson from HP about their efforts. But there's been adoption in different areas. The states of Washington and Maine have actually specified green screen as a form of, as a method for alternatives assessment as part of their regulations around children's products. A number of companies are using it to identify safer alternatives. The GC3, which is the Green Chemistry Commerce Council, a meeting being held next week, is looking at 9 alternatives to phthalates as plasticizers. You'll hear from HP. PINFA is a European flame retardant association for non-halogenated flame retardants. Companies like Walmart have used elements of it in their chemical screening. Nike has adopted the hazard assessment approach in theirs. The Works is using it. And we continue to work very closely with DFE, iterating. They make changes, we make changes. But we're coming to a place where we can harmonize the hazard classification piece, which is, I think, very important because we need to speak the same language when it comes to hazards. So how to do a green screen assessment, and I'll go fairly quickly here. The first step is to assess and classify the hazards, and again, that's the piece we want to harmonize as well as possible with national, international precedents. Applying the benchmarks, that's something that is unique to green screen, but other people may interpret the hazard information differently. And finally, the goal is to use the information to make informed decisions. So the hazard endpoints. Currently, there are 18 hazard endpoints in the green screen method. They include carcinogenicity, endocrine activity, others for chronic effects. You've got neurotoxicity and other more acute effects. You've got environmental toxicity and fate. And then physical hazards, such as reactivity or flammability. And to assess a hazard, and this is pretty much the hard part, I would say, of applying the method, you first need to identify what are all the chemical constituents and relevant transformation products. Debbie talked about thresholds, not necessarily de minimis, but a threshold. How do you even consider which chemicals to look at? Then you collect and you review the data. You assign a level of concern for each hazard and a level of confidence. And then you fill in the hazard table. It's very important to consider transformation products. Some transformation products are more hazardous than the parent compound itself. And that impacts the green screen score. It's included as part of the benchmarking system. You want to avoid unintended consequences. So for example, alkyl-phenol ethoxylates can convert and biodegrade aquatically into alkyl-phenol. And so it's important to address known transformations such as this, because this has endocrine active properties. The next step is to collect and review all the data, and I mean all of it. You go through the scientific literature, the toxicology literature. You can use hazard lists and risk phrases internationally. You use summary data sets from existing risk assessments, things like that. You use models and structure-activity relationship and structural analogs and apply expert judgment. You use all of this. And then all of the criteria for each and every endpoint are up on the Clean Production Action website, so you can download this. But this one, for example, is for reproductive toxicity. And so here we've used GHS guidance, which is very general and doesn't always include numerical thresholds. And you look at the data and you determine if it goes into the high, moderate, or low. We've got some references to risk phrases, hazard phrases, to help with speeding the process when that information is available. And the moderate category is pretty much a pretty big net. That includes even things like marginal evidence of reproductive toxicity. And then the final step here is you use bold letters for high confidence and you use italic letters for low confidence in the hazard table. And high confidence would include good test data, strong analogs, authoritative lists. Italics would be modeled results, screening results, weak analogs. And then the next step is to fill out the hazard table. And that's really where a lot of work and sometimes a lot of expertise comes in. Where you don't have any data, And I mean, you don't have nothing in the literature, nothing you can model, nothing, no analogs to use. You put a data gap. And again, here you have italic, bold convention. And that came out of DFE as well. The next step is to apply the benchmarks. And the benchmarks are what links that hazard table to a really practical application. And there are 4 benchmarks. And benchmark 1 is bad. Benchmark 4 is low hazard. This one you would say avoid. It's a chemical of high concern. This one prefer safer chemical. Not non-hazardous, but low hazard across the board. And each one of these comes with a set of tests. And you would ask each and every one of these tests. And if any of them are true, then it's a benchmark 1. If none of them are true, you move up to benchmark 2. And the definition of a benchmark 1 chemical aligns with regulatory drivers, REACH, Canadian Toxics, EPA. It's the things, and the things that Debbie talked about too, carcinogens, mutagens, reproductive toxins, PBT, CMRs, things like that. We call those benchmark 1 chemicals. So let's take an example. Here we have a fully populated hazard table, which doesn't happen that often, but we have one here for phenol. And we're going to ask the question, is it a benchmark 1? So as I mentioned, you ask the question, is it high for P, D, and the appropriate toxicity? If no, go on to the next question. Is it very persistent, very bioaccumulative? No. Likewise, VPT. Lots and lots of acronyms here. VBT, no. High, group 1, human toxicity, no. This one is not a benchmark 1 chemical. So then you go on to benchmark 2. Same exercise. Is it a PBT at the moderate level? No. Is it a PB? No. Is it high P, moderate T for those endpoints? No. High B, moderate T, etc. Moderate toxicity, group 1. Oops, that's backwards. Okay, very high T for ecotox, group 2. Yes. And also for the final one, oh wait, no, that is right. So there are 2 of these that are positive, but all it takes is 1. And so this chemical would be considered a benchmark 2 chemical. That's how it works. So you need to populate that table. But as I mentioned, there are often data gaps. That's the norm. So you need to evaluate those data gaps because a chemical lacking important data cannot be assumed safe. Okay? And I don't have time to go into it, but when we talk about important data, sometimes that's up to you to decide. If you know that something's going down the drain, then aquatic toxicity data and biodegradability data are important data. If you know something's going to be burned, you're going to need to know what are the combustion products of it. So there's an element of judgment that has to come in to the user of green screen information. But you want to reduce your chance of selecting a bad substitute. And you want to provide an incentive for companies to produce data. And you want to reflect the level of uncertainty. So the strategy we've developed here is to set data requirements for each benchmark level. And it's described in the guidance, which is online. So chemicals that are missing important data are either downgraded to a lower benchmark, or they're just deemed as unspecified, which gets the letter U. As opposed to a 1, 2, 3, 4. So, for example, if a benchmark 3 chemical, like all the data look quite good and it reaches a benchmark 3, but it fails the data requirements for benchmark 2, then you bump it down. Oh, no, I'm sorry. That would be unspecified. There's not enough data to even say much about it. But if it meets benchmark 2 requirements, you would call it, even though it has the benchmark 3 hazard, you would bump it down a level because of its data gaps to a benchmark 2 and just specify that's because it has data gaps. And that provides really a built incentive to fill those data gaps. If you have the potential to bump that up a level, that can be quite an incentive. Finally, the last step of green screen assessment is to make informed decisions. And what you can do here is if you're considering additives of some kind, you've decided you need a solvent, you need some sort of reagent, you can pull together all of the chemicals that perform a particular function that you're considering for your application, and you can sort them by benchmark. So this is where you can connect all that hard toxicology work can now be translated very simply to a purchaser or to a product designer who really would not be very comfortable translating hundreds of pages of toxicological information. So the value of the green screen really is that it provides a structured approach to evaluating a comprehensive set of human and environmental health and safety data. It distills complex hazard evaluations down to an easily understood hazard table, and then further provides a decision logic to assign a simple benchmark score based on a combination of hazards. And as I mentioned before, those hazards are based on national and international logic. It aligns with the REACH definition of a substance of very high concern. So we built that regulatory logic into the benchmarking system. That doesn't mean that other chemicals that are hazardous are fine. That just means that it's consistent with a framework of identifying chemicals of concerns to governments from numerous countries. You can use that information to select greener, safer chemicals to support the health of users, consumers, workers, and the environment. But it's not a replacement for thinking. It's not intended to be that. It's, if you see, people often ask us, what do I do if I have two benchmark 3 chemicals? Well, you look at the hazard table and you make a decision. If you know that worker exposure is via inhalation and you don't have good inhalation data, you don't have enough data to make a decision. Or if you know you might have a benchmark 3 chemical and it's irritating to the eye, that's not going to make a good eye wash. So again, this is not a substitute for thinking, but it is a way of organizing information, digesting it down, and then if you want to use the benchmarks, you can as an initial sort. You still need to even do risk assessment and risk management on top of your selections. It's not a replacement. So what I think the green screen really is, and this is was music to my ears when Jonathan Plisko from Poly once said this, they make alternatives to PVC cable coatings. And they supply halogen and phthalate-free products that meet all the performance requirements. They pass all the appropriate tests. And they got engaged with green screen through HP, and you'll find out why shortly. And they're committed to using CHA and the green screen to develop cleaner, greener products as part of their corporate responsibility. But what he said is very simple. He said, the more you know about what you are putting into your products, the more likely you are to make better choices in product development. Simple as that. So that's what I think is really the ideal use of a tool like that, and I hope I gave you a little sense of what it is and what it isn't. And we'll have plenty of time for questions, and I think that's my last slide. Yeah. Okay, thank you.
Our next speaker has worked closely with the green screen in the context of material selection. Cory Robertson is an environmental chemist with Hewlett-Packard. His first 10 years there were with HP's material science lab. He did analytical chemistry and provided material science support there for laser jet printer and other technologies that I'm sure I've struggled with. In the last 2 years, Cory's role has shifted to implementing the principles of green chemistry, selecting materials for HP products that are inherently safer with respect to human health and the environment. In that role, Cory has worked closely with the green screen. He uses it in HP's product design process. But in doing that, he has also participated actively in the ongoing development and refining of the green screen framework. Although I understand that today is the first time that Lauren and Cory have actually met in person. They've worked together over the phone and various other tele methods for some time. Cory holds a bachelor's degree in chemistry from Boise State University, and I understand that as of the end of this month, he will complete a master's degree in environmental policy and management from the University of Denver. So come on up, Cory.
All right, thanks. Can you hear me? It's coming through. Is this mine?
That's yours.
Okay. All right, thanks. Okay, great. Yeah, thanks. It's an honor to be here. Thanks to Meg and Marty for inviting me. And I have to apologize in advance to Dr. Warner. I did not include a picture of his book or the 12 Principles of Green. Lauren already covered it, though, so I think we're good. So Meg provided some questions, kind of based on what she thought you would be interested in our use of the green screen at HP. And kind of the first question is, how are we using it? And so Lauren kind of already showed this picture. So making a list of different chemicals that are used for the same function. So this could be flame retardants, plasticizers, showing which ones are the good ones, which ones are the bad ones, and then our design engineers can look at those lists and understand which materials are the better choices. Lauren talked about the GC3 project at the UMass Lowell. We're pretty excited about that. So that will be hopefully a published list of plasticizers showing different green screen scores, so that and we can provide that to our suppliers. Give them a reference of these are the materials that you should pick from, and that kind of gets at the idea of a white list. So Debbie talked about this earlier. Regulators are good at putting out black lists. NGOs are good at putting out black lists. So we always ask, how about a white list? Tell us what we could use. So we also use kind of a database approach. So these are different plastics that would be used in products, structural plastics that would go on the outside of products. And so we actually kind of survey the suppliers for information about their products. And one of the things we ask them is to do the green screen assessment. And you can see the benchmark score right there. It turns out that other information like eco-labels, does it meet EPEAT requirements, EU, Flour, Nordic Swan, those are also really important to our design engineers. So kind of putting all that information in a table is really helpful. So kind of an important part of doing the green screen assessment is, where do you do it? And our approach has been to do the green screen assessment early, first in the process. So kind of early on, you deselect the options and put them, we call it the parking lot. So the benchmark 1 materials, we kind of set those aside, and we only want to use those as a last resort. And then if there aren't good alternatives, then we'll go ahead and use benchmark 1, and then we'll go into other kinds of thinking like life cycle thinking, exposure assessments, risk assessment, that kind of thing. But kind of start off with doing hazard assessment first, get the benchmark 1 materials out quickly. But kind of the highlight of our how we're using the green screen is our PVC-free power cord project. So PVC is being phased out. Most of our power cord cables today are still PVC, but we anticipate that that's going to change in the near future. So switching to a better alternative is important to us. We don't want to just switch to something that's not regulated. And so applying the green screen is an important step in that. So we require our vendors to perform a green screen assessment on their alternatives as part of our HP requirements to supply to us. So this usually requires full disclosure of their materials, and so that you can imagine there's a lot of wrangling back and forth on that. But they do disclose their formulations to us so that we can review the assessments. We did have a supplier training 2 years ago to kind of kick this off, introduce it. So we had all of our suppliers come to Fort Collins, Colorado, and we went through the green screen, how to do it, who can do it for them if they don't want to do it themselves, all that kind of stuff. So that was an important part. So communicating green screen. And we've had over 30 formulations submitted. Some have been approved and some have been rejected. So we think it's been a success. So the other question is why? Why are we interested in the green screen? So Ross, you guys have probably all heard of Ross, but that kind of turned the electronics industry kind of on its head, with banning these 6 substances. A couple of the PBB and PBDE were already banned by HP in the early 90s, so those kind of weren't as big a deal, but the lead was obviously a big deal. And kind of the important part about Ross is they kind of took a different approach. They were looking at the waste stream. So, what were the problems that were, coming up with e-waste? So e-waste is a big deal for the electronics industry. And, how could they fix that? Well, they could prevent. Prevention is the cure, I guess. But one of the early questions that came up, as you can probably well imagine, is, are the alternatives even better? And we need a good way to talk about that and to understand which alternatives really are better. Another reason we're interested in is, we're getting swamped with regulations, and they are looking at the substance level. There's more jurisdictions, more reporting, so there's just lots more legislation. And we want to use the materials that no one cares about. We want people, to, not have any interest in the materials that we're using. And HP is a business, so cost always comes in. So you can imagine this phthalate is being restricted in July 2014. We could move to another phthalate and then a second phthalate and finally maybe a non-phthalate that's really the preferred option, and that could be 3 times the cost. We could go 1 phthalate. But what we really want to do is just go straight to the chemical that no one cares about, the non-phthalate, and we can save some money doing that. So what are some of the strengths of the green screen? One of the big ones is it aligns with what the regulators are doing. So we want to get ahead of the regulations. We want to know what materials are likely to be regulated. And sort of, in order to do that, we need to think like a regulator. And so this kind of helps us do that. So they're using the same criteria in a lot of cases as the EPA Design for Environment. And we talked about the GHS system as well. So aligning with those methods as much as possible is in our interest. And so, yeah, a cartoon, I guess. If you're like me, you're grateful for these breaks, where you can not think so hard, I guess, and look at cartoons. So a procurement person, they're very good with numbers. They pick the one that's lower cost. That's a good thing. But when you put environmental decisions, paper or plastic, it's a little bit harder for them to decide. And especially, paper or plastic might be a little bit easier, but if you're comparing things on the left, aquatic toxicity, bioaccumulation, is that worse than this chemical that is persistent and has mutagenicity or something? So they're not toxicologists. They're not going to do that. So the green screen helps them make those decisions. So benchmark 4 is the right choice. All right, so what do we need? What needs to be developed, I guess, in the green screen? So we need a validation process. So we need a way for suppliers to communicate with other suppliers about the green screen scores of their materials. So a flame retardant supplier needs to be able to tell a resin formulator this material is green screen benchmark 2, and that needs to mean something. We need the repository, so that's kind of a database of green screen assessments that we can send our suppliers to so that they can see what are the scores of the materials that they're looking at. White lists, as we talked about. There's some issues with the inorganics. They tend to score very low because they're kind of naturally persistent. We've worked through that quite a bit back and forth, and I think we've got a pretty good solution to that. We need more users. Lauren showed, Ford, Nike. We need lots more input, more size, and there's lots of benchmark 2 chemicals. So it seems to be most chemicals end up in that benchmark 2. So it's kind of difficult to differentiate. They kind of all look the same, I guess. So you could say we need more benchmark 3s and 4s, but sometimes everything looks the same if everything's a benchmark 2. So and then issues around confidential business information. As Lauren kind of said, knowing about the materials in your products helps you to make better decisions. So we know a lot more about the materials in our products. We get formulations from our suppliers that we can look at. And we need to know all of the ingredients, so we have to, usually it requires a confidential disclosure agreement. And suppliers have told us, we would provide this information to HP, but maybe not a smaller supplier, certainly not a competitor or someone that's affiliated with a competitor. So there's definitely there's some information HP can get that other suppliers might not be able to. Ideally, what we'd like is for the formulations to be verified by a third party, and then we wouldn't have to even see the formulations. We would just be able to get the score. But we know that the infrastructure isn't ready for that yet. It needs to have that validation process. And there's definitely a material dependence. Roger McFadden's here. He gave a great webinar the other day about a kind of an informal study they did on MSDS information. So this is an MSDS for a battery. On the top, it shows lots of information. It shows everything that's in that battery. But when you get into a polymer, oh, it kind of cut off there. Basically, it shows that there's only one ingredient, and it's 0.1 to 1%. So you don't get much information from polymer companies. So it's definitely a material dependence. So what's changed because we're using the green screen at HP? So we're kind of skipping through the supply chain. For a power cord, we buy from a cable vendor, and they buy from a resin supplier, and the resin suppliers talks to flame retardant suppliers and things like that. So we're actually talking to the formulators and the flame retardant suppliers, where we weren't doing that before. And so kind of the statement, if we articulate environmental requirements to our suppliers, we're going to get better materials. So we need to give them something to shoot for. And some of the things that the suppliers have said, maybe we should pre-screen our materials before we send our formulations. Yeah, that's right. So we're getting the message across. Our customers are asking us about HP requirements. So I think this flame retardant supplier was kind of saying it in a negative way, but we kind of spin it the other way. HP's telling you what we want, and we're kind of laying it all out there for you. So you could spin it a positive way too. And then finally, some surprises. So many of our suppliers, want to talk about their frameworks that they have. So they have kind of some internal chemical hazard scoring systems and things. So they're kind of already doing this, but there's not a common language. And so having the green screen can provide a common language that we can kind of all understand. Within HP, a lot of people know what benchmark 1 and benchmark 2 and benchmark 3, they understand what that means. So having that common language. And suppliers have additional toxicology data that isn't publicly available. I don't know if that's too much of a surprise, but it was a little surprise that they were willing to share it with us, I guess, when we asked for it. But there is more information that they have that, isn't shared. So that's a little bit of a surprise. And then finally, just asking our suppliers to do the assessments motivated them to remove some chemicals from some formulations. So getting to Debbie's point, is it necessary? Well, obviously, some of the ingredients weren't really necessary. So I think that speaks volumes for what they're doing. And that's it.
Thanks very much to both Lauren and Cory. And we designed this session to have a short history of each of them and a time where there would be discussion between a creator and a user of green screen, and also invite audience questions. Because we started a little bit late after the break, we're pushing that edge a little bit, but I'm going to ask to borrow maybe 5 minutes from our copious, spacious lunch hour and a half to make sure that we get a little bit of discussion time here. Are you folks blinded by green light right now? You have the.
That's all right.
Let's see if I'm not sure we can. That's no better. Okay.
The green is better.
Move.
Turn it
Green
on.
is better.
Thanks. We'll make it go away. So I want to open it up to audience questions in a moment and just not monopolize it with my question, but I want to lead with one, which is putting green screen in the context of green chemistry, I feel like is helpful because it really highlights, in particular, the motivation of creating the benchmark 4. So I'm interested in this category of benchmark 4. We know how to identify a lot of benchmark 1 chemicals, but ideally everybody is looking, instead of just to move away from hazardous substances that have been identified, to actually identifying safer ones. And so I'm curious if either of you have reflections on, Lauren, how green screen has been able to define a benchmark 4, and Cory, have you been able to identify benchmark 4 chemicals? Are you finding that white list, and what's your experience with that?
Yes, the benchmark 4 is defined as low hazard across the board. And as I said, that's not zero hazard, but there are cutoffs and thresholds defined in the globally harmonized system and through OECD and EPA for what low hazard is. For example, over 2,000 milligrams per kilograms for acute mammalian toxicity, something like that. And also it would be low for persistence and bioaccumulation and aquatic toxicity, et cetera. And as Cory mentioned, we ran into some issues with inorganics, which are highly persistent. But you have to ask yourself, is beach sand really, does not deserve to be a benchmark for chemicals? So we ended up looking at a lot of criteria around solubility and what moieties are formed and whether those moieties themselves are reactive or not, so that it is possible for a very stable inorganic material to become a benchmark for as well. And as I mentioned, green screen, it deals with the hazard piece. And we heard about some elegant synthetic chemistry. It doesn't address that piece of it. It could address reagents used in the synthetic chemistry or catalysts used, but not the process itself. So we think that that goal of a benchmark for chemical is very ideal. I think we may have seen a flame retardant that is a benchmark for. It'll depend on the breakdown products, but it's also used as a fertilizer. So that's a hint. Some of you might guess what it is. But it's pretty benign. And so that would be pretty nice for a benchmark for. But benchmark 3 is very good, too. The benchmark 2s, as Cory said, there's a lot of them, and you need to apply very discerning thinking. Use caution with the benchmark 2s, but those aren't the ones that are probably going to attract the regulations.
Yeah. So the benchmark 4s are pretty few and far between, so they're hard to find. But had an interesting conversation with one of our flame retardant suppliers. They're interested in what's the market for a benchmark 4 flame retardant, and we think that market would be great. But on the other hand, making the case for moving from benchmark 1 to benchmark 2, that's very easy to do with our management, I think, because there's regulations involved and things like that. But moving, from a 2 to a 4, that's a little bit harder to say, it's worth a cost increase or things like that. And we've had definitely lots of marketing studies that show that the customers buy on environmental kind of as a secondary choice. But if it costs more, then they don't usually pay more for it. So that's kind of where, how do we create the market for those benchmark 3s and 4s?
That's interesting, Cory. So do I hear you saying you want the regulatory floor to be set at a benchmark?
Yeah, that is definitely one way to do it, I guess.
I have more questions up my sleeve, but I want to open the opportunity to the floor. And there's a microphone that'll come around.
Thanks. Eileen Sheehan from US EPA Region 9. I just wanted to ask about green screen and how it can or cannot incentivize product design changes. So Lauren, that first table you put up about flame retardants in foam, there was a great debate at EPA about, it's all about the chemical substitutions, alternatives. But there are design changes that will inherently flame retard a product. And I know HP actually pioneered some of this with their printers and then I think ran into trouble with the fire marshal. So I'm just curious if you could comment on the green screen and this larger question of design changes as opposed to chemical substitutions.
Sure. Yeah, my understanding, according to Helen, and correct me if I'm wrong, is that in the way HP applies the green screen framework is if you eliminate the chemical altogether, that's considered a benchmark 4 option. Is that correct?
Yep, that's right.
Yep. So you can eliminate it completely. It's not intended to lock anybody into a chemical substitution framework. Clearly, as part of an alternatives assessment process, you need to consider redesign, because very often there aren't good drop-in replacements or even good replacements that you can handle with enough reconfiguration. So that's a very important part of alternatives assessment.
And I guess along those lines, so I think that the green screen kind of sets up a framework, a kind of a common language. So one of the things we've talked about is maybe EPEAT could be interested in using the green screen and setting.
Do you want to say what EPEAT is?
Oh, I'm not exactly sure what it stands for, but it's an eco-label. An eco-label that's from the EPA that computer products need to meet quite often in order to qualify for certain contracts. But if EPEAT were to pick up on the green screen and require a certain benchmark level or something, then that could we definitely design products to meet EPEAT Gold or EPEAT Silver. And so if that was a requirement, then we would definitely design products to meet that requirement.
Yep.
Irv Levy from Gordon College in Boston. I think this green screen sounds great, but I do have one question. How do you deal with the complex possibility of the way one substance may potentiate the hazard of another when you look at these low-level hazards? And is there a way the green screen hopes to deal with that, which seems like sort of an exponentially complicated problem?
Yep, very good question. Right now, the green screen does not have a method for rolling up to a sort of score of a mixture or a material. What it does is it identifies each and every constituent, the hazard table, and the benchmark. And so what you can do is look at a particular formulation, say, and understand what it's made of. And but the next step, as I mentioned before, is to apply a risk framework and to look for things like synergisms or additive effects. And but we don't always know how things are being used, and we've sort of tried to draw a box around this to make it as useful as possible, but not too prescriptive. And so that would be the next step. I was talking to someone from J&J recently, and hazard assessment is a very important part of that, about how they select materials, but they do a lot more testing. They do product testing to make sure there aren't synergistic effects. So that's a very important piece. You need to apply more thinking on top of it once you've identified safer alternatives.
Yeah.
Should we do one more question?
Oh.
Marty wants you to come up. There's so many. Oh, there's one in the back.
I actually can talk pretty loudly.
Okay.
Hi, I'm Andrea with Clean Water Action, and
I'm always looking at these things of how are we going to drive, the development of safer alternatives as opposed to just looking at what's already out there. And you brought up a very good point that, your bean counters need to look at, is there a market? Is the consumer going to pay a little extra? And of course, the consumer doesn't know what they're paying for. They don't know all of this is going on necessarily. And so I'm wondering, at the end of the day, though, when you look at the cost, how do you determine whether you have to add cost to the product, or whether you're going to make up some of that cost because you're dealing with less toxic materials, you're not having to manage that, all of the costs that go along with that? Where does that play into those decisions so that you would go to a benchmark for?
Yeah, so I guess as far as the cost, we can get that information from our suppliers. They'll tell us how much more it's going to cost. Usually they come in with a high number, it's going to be 3 times as much, but when you talk about volumes and things, the price comes down over time. But yeah, that is a tough one. The businesses kind of have to make that decisions. But I mean, the people that do the marketing and sales for the business kind of have to decide, what kind of marketing clout, will be important. So yeah, it's a tough one. And usually, unfortunately, the answer is, it doesn't buy you much in sales. So that is a difficult question to answer, yeah.
Thank you so much, both Lauren and Cory, for coming and joining us today.
Thanks.